this example for lesson 4, we're asked to solve a radical equation where the answer is also a variable. So we're asked to solve the square root of 9x plus 10 is equal to x. And so since there's no other terms on the left side besides the stuff inside the square root, let's square both sides of the equation as our first step. So we're going to square that, and then when you square a square root, the square root cancels out and you're just left with 9x plus 10. And then on the right side you have x, it's not inside a square root, so x squared is what you have there. And now since you have a linear term, the 9x, and a squared term, quadratic term, which is x squared, we can't just solve for a specific number. Our approach is going to be to try to factor to see what numbers would make this statement true. In other words, we're going to start by moving all the terms from one side to the term that has the x squared. So we're going to subtract the 9x from both sides and subtract 10 from both sides. So since it's plus, we're going to minus. If it was minus, we'd add. So then our equation becomes, on the left side you just have 0 since everything canceled out, and you have x squared minus 9x minus 10. And so this is where the factoring part comes in. So we're going to look for two numbers that multiply to give me my last term, the constant, which is in this case negative 10, and at the same time those same numbers would have to add or subtract in order to give me negative 9. So the question is, what multiplies to negative 10 and at the same time adds to negative 9? Now I know like negative 5 and 2 for example would work, but then if I do negative 5 plus 2, that'll be negative 3, not negative 9. So the only two numbers that are really going to work is negative 10 times positive 1. And that's negative 10. And then if I add that, negative 10 plus 1, that's negative 9. So that means my factors, how do I break this down? I can break it down into x, since this is minus 10. That's going to be one of my factors. And then my other factor is going to be x, since this is positive 1, plus 1. And I'll set it equal to 0. And so now I'm saying, what I'm asking is what numbers would make each of these factors 0. So in other words, what minus 10 would make this term, this binomial, equal to 0? And the answer is 10, because 10 minus 10 is 0. And my other answer would be what plus 1. So I have to do negative 1 plus 1 in order to get 0. And so those are the two solutions that work for the problem itself. But as is often the case with radical equations, sometimes an answer comes up as a solution, but it doesn't make the statement true, which is why we have to check for these extraneous solutions. So let's start with the 10, and we'll plug it back in. We'll go square root of 9 times 10 plus 10, and then it's equal to x, so again the answer that we got. And so we're checking to see whether this would simplify to be 10. So 9 times 10 is 90, plus 10, which is square root of 100, and square root of 100 is 10. And so that does work, which means that 10 is a valid solution to this equation. And then let's check the same thing with negative 1. So we'll take the square root of 9 times negative 1 plus 10 and set it equal to negative 1. So that's going to give us the square root of negative 9. 9 times negative 1 is negative 9 plus 10 equal to negative 1. That's the square root of negative 9 plus 10 is 1. And square root of 1 is just 1. But as you can see on the right side, we have negative 1 is what we're checking for. So we got an answer of 1, but when we solved it, negative 1 came up. So these are not the same things, which are not equal, which means that negative 1 is an extraneous solution. So that would not make this statement true. And you could also tell by graphing that the graphs between 9x squared of 9x plus 10 and x won't be crossing. So the only solution to this is x equal to 10.